Okay, assalamu alaikum everyone. Uh, it's 2 p.m. now, so we will start today's class. So, yesterday we started rate of reaction. Sorry, day before yesterday. We started rate of reaction and we discussed about what is rate and we discussed about what is collision theory. We mentioned that uh, particles should collide in order to react. They should have enough energy for the collision for a successful collision. So that means a successful collision means when two particles collide, if a reaction occurs, then it is a successful collision. And we mentioned some of the factors that affect the rate of reaction, one being the concentration, surface area. So when concentration increase, rate of reaction increase because more number of particles since more frequent collision. Surface area, when surface area increase or the particles become or the substance becomes smaller, their surface area increase because more particles will be exposed to the reaction, therefore more successful collisions. And we highlighted about the temperature as well. When temperature increase, rate of reaction increase because particles gain more kinetic energy when they are heated, so more successful collisions. And finally, we discuss about activation energy. Um, the rate of factor of rate of reaction by using a catalyst. That is, when a catalyst is used, catalysts provide an alternative route by lowering the activation energy, and we visualize that information by using a graph. As you can see, there's two graph here, one dotted line. Dotted line means it is with the catalyst. The purple line means without the catalyst. For the purple line, as you can see, the activation energy required is higher than the red colored one, which is the one with catalyst. And we discuss a little bit about how to measure rate of reaction. And today we will go in detail with the measurements, the investigation. So in a reaction, um, if a gas is released, for example, when a metal react with acid, there will be hydrogen gas released. There are other reactions such as carbon dioxide released when acid react with the carbonate, metal carbonate, and carbon dioxide released during a combustion reaction. Oxygen released during the decomposition of hydrogen peroxide. So these reactions you must know. Uh, you must know that when a metal and acid reacts, hydrogen gas is released. So in such reaction, we could measure the amount of gas that is released by using a gas syringe. So this is the apparatus. As you can see, gas syringe is you can use to collect and to measure the temperature, to measure the volume of the gas evolved. And in order to measure the rate of reaction, what we have to concern about is how much volume of gas is collected over time. That's why we have to use a stopwatch. Uh, so it is up to us whether we have to take the measurements in seconds or in minutes. So before we start the reaction, we have to clean the magnesium with sandpaper. Why do you think we have to clean the magnesium with sandpaper? Anyone have any idea why? Give me a minute. Is mentioning to remove the impurities in the surface. Yes. What is the main impurity for a reactive metal? What will be the surface main impurity? What do you think? Oxygen? What do you mean oxygen? Oxygen is an impurity? You mean the oxide layer, right? Yeah. Yeah, you have to give the answer properly. Okay, don't just say oxygen. The main impurity uh, will be the oxide layer. So when a reactive metal is exposed to the atmosphere for quite some time, a reactive metal will start to react with atmospheric oxygen to form the oxide layer. That is true for aluminium as well. From starting from, if you remember the reactivity series, starting from aluminium to sorry, starting from sodium, potassium to aluminium. Those are considered as reactive metals. So sodium, potassium, magnesium, calcium, and aluminium. They will form oxide layer. If an oxide layer is formed, the oxide layer will be much more stable. So which means if magnesium has an oxide layer and if it is added to hydrochloric acid, then the reaction that we are intended to achieve will not be the correct result. So you have to be careful. Magnesium oxide is a base, right? In that case, hydrogen gas will not be released. So uh, we then put the dilute hydrochloric acid in the flask and we drop the magnesium into the flask. Now, once we immediately drop magnesium, it immediately starts the reaction. So that, and immediately hydrogen gas will be released. And you have to immediately put on the gas syringe top, that is the flask top with the delivery tube. So this way the reaction to start the reaction, and also we have to start the stopwatch at the same time. So that will be a very big inconvenient. So usually magnesium is not added in that manner practically. Usually there will be a small test tube inside the flat bottom flask. This will be the flat bottom flask, and there will be a string attached to the test tube, and you can tilt the test tube with the magnesium so that the magnesium starts reacting with hydrochloric acid. So there is one method that is usually used, and immediately when magnesium reacts with hydrochloric acid, we start the stopwatch. And when hydrogen begins to bubble off, it rises up into the flask, into the gas syringe, pushing the plunger out. So as you can see from this diagram, before the reaction start, it will be in zero, the scale will be zero, but as the hydrogen gas gets collected, it will start to give enough the reading. So now the plunger has been pushed out to the 20 centimeter cube mark. 20 centimeter cube of gas has been collected, that means. Okay. So the volume of gas in the syringe is noted as intervals. For example, every half a minute or a minute, how will the reaction proceed? How many volume of gas is evolved is recorded in a table like this. So at 0 minute, 0 centimeter cube, half minute, that is uh, 30 seconds, it produces 8 centimeter cube. 1 minute, 14, 1.5, 20, and you record the volume of the gas evolve in equal time intervals. Okay, and by using this table, we draw a graph that contain x-axis will be the time, y-axis will be the volume of hydrogen gas evolved. So as you can see, from 1 minute it produces 14 centimeter cube. So in the test final exam, you will be asked to draw graphs like this. Tables will be given and you will be asked to draw graph like this. Okay, so as you can see, the exact dots, exact points are pointed clearly using a circle, right? So those circles should be clear. If those points that you have to plot is not clear, you will not receive 1 mark. For plotting, there will be 1 mark. Okay, and as you can see, it starts with 0, so 0 is also marked, and then it is each point is connected through a smooth curve, not a straight line. I have seen some students draw straight line from here. Do not use straight line. Do not use ruler when draw curve like this. Okay. Then, so we can see a curve that increase, and then after some times it gets flattened. It gets horizontal. We have to check what is the meaning of this. So when we talk about rate of reaction, how can we find the rate of reaction? By using this curve. As you can see, in the first minute, 14 centimeter cube of hydrogen is produced. So first minute, 14 centimeter cube is produced, right? So the rate of the first minute is 14 centimeter cube. So that means rate is how many volume per minute or per second. In this case, it is per minute. So we take as per minute. Okay. All right. Now, in the second minute, there's 25 centimeter cube that is produced, but the rate will be the volume per minute. So starting from the first minute to the second minute, in between this is 1 minute, right? In between how many produce? That is 25, that is the one produced in second minute, minus 14, that is the volume produced in the first minute. So the volume produced in between first one and second one will be the rate of reaction. Okay, this is also called the gradient rate of reaction. So it will be 25 minus 14, 11. For the third minute, we similarly we subtract from 25 to third minute, we it produce around 31 to 33. So you will get 8 centimeter cube. So as you can see, first minute it was 14, second minute it was 11, third minute it is 8. The rate of reaction decrease over time. Why do you think the rate of reaction decrease over time? Why do you think the rate of reaction decrease over time? There will be less to react. Yes, there is a limit. Malak answer is much more appropriate if you include the concentration, the word. There is less amount of reactants. Okay, there's less amount of reactants that is available, because it is a reactor that is reacting, right, to produce the products. If the amount of reactant is decreasing, meaning the concentration is decreasing. When the concentration decrease, less molecules will be there. Less molecules means less collision will be there. So that means less successful collision, which means rate decrease. All right. You should be able to answer in that manner. Whenever you are asked why rate decrease, why rate increase, always explain the answer in terms of collision. All right. And now the rate changes or the reaction, it is greater at the start but decrease as the reaction proceed. So we can just say that the reaction is fastest at the beginning and the reaction is slower just before the reaction ends. Which point we know the reaction is over? When the curve gets flat, that means when the curve get horizontal, then we say the reaction is over. All right. So we have to pinpoint to exact which point the value that you are getting here, it's getting repeated. All right. For example, here you are getting 100 centimeter cube. So at 5th minute, you are getting 100 centimeter cube. 6th, you are getting 100 centimeter cube. 7th minute, you are getting 100 centimeter cube, which means the reaction was over at 5th minute because the same value gets repeated. Okay, there's no more increase in value. No, that means no more gas is evolved. So if you are to find the average rate of reaction for the whole reaction, this is the formula that you have to use. The total volume of hydrogen produced divided by the total time for the reaction took place. So by looking at the graph, can you tell me what will be the average rate of reaction? By looking at this graph, can you tell me what will be the average rate of reaction? Can you identify? It is the volume divided by total volume divided by total time. What will be the amount? Eight centimeter cube per second. Why per second? Per minute. Per minute, yes. 8 centimeter cube per minute. How you got 8? How you got 8? The total volume will be 40, and the time it took for the reaction to complete was 5 minutes, because at 5 minutes the flat just got flattened or horizontal, right? So this time we have to take. Right? You have to be very careful with that. Sometimes many students, they just take 7. So yes, 40 divided by 5 is equal 8 centimeter cube of hydrogen per minute. 8 centimeter cube per minute. And you have to mention the
this next idea. We could collect the gas produced. How do we collect a gas? One method is to use a gas syringe. Look at this. Here we have magnesium reacting with hydrochloric acid. Hydrogen gas is produced, As the gas forms, it rises and pushes the plunger of the gas syringe back. We can then measure the volume of gas produced in a specific time. There is another method we can use to collect a gas to measure it. That is by the downward displacement of water. You see, we can collect the carbon dioxide when a carbonate reacts with an acid. We fill a measuring cylinder with water and carefully turn it upside down. Then we place a delivery tube from the flask to the mouth of the measuring cylinder. We can now catch the bubbles of carbon dioxide. The carbon dioxide pushes the water down. We can then measure the volume of gas produced in a certain time. We have just seen some methods of collecting a gas to measure the amount of gas produced by a reaction. We can also measure how much of the reaction mixture is left behind when a gas is released. Can you think of a way to measure the reaction mixture? If we let the gas escape from an open container, the reaction mixture will decrease in mass. We can then work out the reaction rate by working out the change in mass in a set time.
Amira gave us a lot to think about. Let's recap. We saw that a practical way to measure the reaction rate is to measure the amount of product formed in a given time.
So what you have seen is actually three methods to measure the rate of reaction. All right, three methods to measure the rate of reaction. What I've explained is just one method. So we have to learn, we have to be familiar with some of the methods that is mentioned in the syllabus. So as you can see from the second method from the video, if you are listening carefully, that was by using water displacement. And if you are, for example, if you are investigating the rate of reaction about the surface area, all right, so you can set up the apparatus like this. You may be asked to draw, setup, and a label for around 2 marks or 3 marks. So rate of reaction is one of the few topics in which you will be asked to draw the setup like this. Okay, so here you can see there's a conical flask. Inside the conical flask you have acid, and there is a funnel here. From this funnel the other chemical will be added. So if it is any other carbonate should be added, it will be added from here. And this is a delivery tube connected to the gas jar or measuring cylinder. Usually measuring cylinder is used because you can find the volume of the gas that is evolved. So when the reaction proceeds, the gas produced will pass through the delivery tube, bubbles up through water, and collected over water. As the bubbles or as the gas is collected, the water level will go down, as you have seen from the video. All right. So as you can see, the water level now it's going down as the reaction proceeds. In this way, you can identify the volume of the gas evolved per time. So the idea is the main idea is we are identifying the amount. So the amount can be volume, the amount can be mass as well. All right. So as you have seen from the video, the third type of the reaction in which there was a conical flask placed on the balance. So in that case, we find the decrease in mass over time. And then what we do is we repeat the same apparatus by affecting its rate of reaction by changing the conditions. For example, if in the surface area, when we talk about surface area, we decrease the size of calcium carbonate that is used. So we make it in powder form in the second experiment. The first experiment, we use larger lumps. The second experiment, we repeat the same by using powder calcium carbonate. So in that way, you are increasing the surface area. All right. So this is another similar type of reaction in which concentration is one main factor of rate of reaction. Here, an acid is added to something called sodium thiosulfate solution. Okay, sodium thiosulfate solution. Now there is a cross mark placed on a white paper, and the beaker is kept on that cross mark. All right. So when acid reacts with thiosulfate, there will be change of color. The solution becomes opaque or transparent. So the cross mark is to visualize the change in the color for the solution. So we stop the timer when the reaction is complete. The reaction is complete when the solution becomes opaque, which means there will be a strong color. And we repeat the same by using different concentrations. And we measure the time taken for the reaction to complete, or for us to visualize how much time it took for the X to disappear. All right. Let's see a video of that as well.
Faster the color changes, the faster the reaction. Let's look at the iodine clock experiment to see how the color change shows the rate of the reaction. The reaction happens faster with more concentrated solutions. Do you know how we could measure the reaction rate of a reaction?
So there are some reactions that change color as the reaction proceeds. That is the main idea here. All right. That change of color idea is used in the rate of identifying the rate of reaction, the change of color per time. So these are the points that you must mention when you are to explain the method, when you write the procedure. Usually these kind of reactions will be asked in your paper 6, the alternative practical. Around 6 to 7 marks there will be one question specifically for designing an experiment. So in that one, you will mention the apparatus used, you will label the diagram, you will mention the procedure, and then you will mention the result as well. Now this is the similar type of reaction, but in this case, the factor is temperature. So you do the experiment at a specific temperature over water bath. Usually water bath is used for gentle heating. All right. And similar idea, the reaction is measured, the time is measured, and usually um, the quantities are mentioned in a table. You have to mention that as well. That should be recorded in a table. How much time it took for each temperature for the reaction to dissolve, for the reactants to dissolve. That is the main idea here. Again, a similar kind of reaction. In this case, a catalyst is used, hydrogen peroxide. So the reaction first, uh, hydrogen peroxide solution and a chosen catalyst is used, and we measure the volume of the gas released. And we repeat the experiment without using the catalyst, and we compare the results, whether catalysts really do affect the rate of reaction or not. So these are the reactions, these are the methods or investigations, that is to check whether the factors that is mentioned, that is catalyst temperature, concentration, is really affecting the rate of reaction or not. All right. Then when we talk about rate of reaction, we have to be mindful of something called photochemistry, photochemical reactions. I think you might have heard about this when you talk about, when you learn air pollution in grade 8, I think grade 9 also, I think some amount is mentioned. What is photo means? A photochemical reaction has something to do with photo, right? Photosynthesis, there is photo at the beginning. What is this photo really means? Light, yes. Photochemical reactions has to do with something about light. Usually it is the radiation from the light. Right? Light we are talking about the sunlight. Sunlight has many different kinds of radiation, ultraviolet, infrared, right? Many kind of radiation is there. So this radiation is the main condition that is used in order for these reactions to occur. So one reaction that you have learned in when you studied alkanes, they undergo substitution reaction, right? For example, methane reacts with chlorine to form chloromethane and hydrogen chloride. Both hydrogen chloride and chloromethane will be in gaseous state. And this is the same idea that is what's happened in ozone depletion as well. The radiation from the sun is used to breaks down the chlorofluorocarbon that produce uh, chlorine-free radicals, which reacts with the ozone layer. So these are called photochemical reactions. That's how ozone at lower atmosphere is formed because of the photochemical reactions, because the oxygen molecules breaks down due to this radiation, and it forms something called oxygen free radical, which is highly reactive. So it bump into another oxygen molecule, form O3, ozone. So that is a photochemical reaction. Any reaction that involves ultraviolet light is considered as a photochemical reaction. Now you must know about this, the silver ions that is used in photography. Now black and white photography film surface contain crystals of silver bromide. When exposed to the light, the silver bromide change into silver and bromine. Silver bromide is colorless at low concentration, but the silver appears gray and black. So parts of the film appears black, gray, or white depending on the exposure. Exposure means how concentrated the silver bromide is exposed or reacted. So stronger light means the film will appear more black or dark gray. Weaker light means it will be more light gray. If it is not exposed means it will be totally white. This is the idea of black and white film was actually first from this idea. It's from the chemical silver bromide. Okay. When it is exposed to the light, the intensity of the color, black and white it produces, differs. Any questions so far? Okay, this is the previous experiment where immediately magnesium ribbon was added, but in this case, as you can see, there is a test tube. Inside the test tube, magnesium ribbon is kept. Actually, in reality, there will be a string attached to the test tube, and it will be you can pull it or pull down the string so that you can release the test tube. But anyway, so it says what is the use of test tube to contain magnesium, so it will not react with hydrochloric acid immediately. Okay. And what is the use of gas cylinder? To collect and measure the volume of gas evolved. How would you get the reaction to start? By releasing or tilting the test tube that contain magnesium. So magnesium will get in contact with hydrochloric acid, the reaction starts and bubbles will start to rise. Question number 2. So some magnesium is reacting with dilute hydrochloric acid and hydrogen gas is released. And there's a table given. The first question, what does an excess acid means? This answer is wrong. What is the meaning of an excess acid? It means the amount of the acid that is used is more than required. To make sure all magnesium metal reacts. To make sure there is no magnesium metal left behind when the reaction is over. All right. So amako excess ko echa berno kurar mi berno kurani deng berno kura reacted ekko use up kura or ekko ngeti a reaction ga ekko dissolve kon. That's the idea of excess. Okay, more than required. Excess means more than what is required. So plot a graph of the result. You should get a curve like this, and you should label the axis. Yes, you have to draw graph freehand. There is no other way. And one more thing which I really forgot to mention. When you draw a graph, you must use, okay, you must use at first when you draw, use pencil with very faint line. Do not try to press your pencil so hard at first time. Use a very faint line first, because sometimes if what you have drawn, if that line is visible even after you erase, since you press it too hard, the line the root will be visible. So when your test paper is taken, a carbon copy is taken, that line will be visible as a line that you have drawn, even though you have erased it. So many students, they lose mark because of that. So it's better to use a rough line in a very soft color, in a soft, very mild manner. Okay, do not press it too hard. And when if you come across any mistake, no, if it is pressed too hard, the root that you drawn the line, that root will be there, right? It will be carved into the paper. That carved in line is the one which will be visible when the carbon copy is taken. Yeah, HB pencil should be used. So why does the rate change during the reaction? The rate decrease because the concentration of the reactants decrease. How much hydrogen was produced in total? 40. How long does the reaction last? 5 minutes. What was the average rate of reaction? 40 divided by 5, so 8 centimeter cube per minute. How would slow down the reaction? So you can mention any factors of rate of reaction: decrease in the temperature, or using the large lumps, or decrease in the surface area of magnesium. Question number 3. Hydrogen peroxide decomposes much faster in the presence of enzyme catalyst. Why? Enzymes are biological catalysts that speed up the reaction by decreasing activation energy. When you explain why catalyst increase the rate of reaction, it decreases the activation energy. Activation energy is the energy that is required to start the reaction. B part. The reaction between magnesium carbonate and dihydrochloric speeds up when some concentrated hydrochloric acid is added. So as the concentration increase, you are increasing the particles per volume. So it will increase the frequency of the collision, increase the successful collision, so the rate increase. So collision part should be there, okay? Powder magnesium is used in fireworks rather than magnesium ribbon. Powder provide more surface area. So that means more particles are exposed. So that means more frequent collision, more successful collision, rate increase. Then question number 4, you have two separate experiments in which two metals A and B reacts with hydrochloric acid. And there's a graph shown. Which apparatus is used to measure the volume? It's a gas syringe. Which other measurement is needed? That is the stopwatch to measure the time. All right. Which metal A or B reacts faster? Now, to check which one reacts faster, you have to check whether which graph is much more steeper. Steeper means the one which is closer to y-axis. This is y, this is x, right? If the steeper means the graph which is much more closer to the y-axis. All right. So compared to A and B, A is much more closer to the y-axis, or A is much more steeper, we say. So A is having a faster reaction because the graph is more steep. So that is the evidence from the graph. All right, steeper. Now next is it's mentioned to draw a curve for metal B. If more concentrated acid is used. So if more concentrated means the rate of reaction will be higher. All right, rate of reaction will be higher, but it will finish at the same level. Same level means the horizontal part will be at the same level, but the reaction will finish much more faster than B. Okay, can we write A takes less time? Yes. A takes less time to complete the reaction. You can mention in that manner. And the reaction is carried out at lower temperature means it will be less reactive, but still it finish at the same point, finish at the same level, but it takes longer for the reaction to finish. All right. Can we write that A, as the reaction has stopped sooner? The reaction stopped. It's better to mention reaction is completed. Okay, completed soon. Stop means suddenly it somehow it halted or stopped. So better to mention the reaction gets completed sooner or quicker. Okay. So these are the some of the basic type of questions. So if we go in this pace, we will be able to finish the syllabus tomorrow. Tomorrow we'll be learning about reversible reactions. So once reversible reaction is over, we will complete our syllabus. So once we complete our syllabus, then we will be focusing on revising previous topics. Yes, you can do past papers. Yes, you can do past papers even now. Carbon cycle is mentioned when you studied pollution, right? Is it not? Don't worry, we will revise. Revision we will start along with when we finish the reversible reaction. We will for the revision we actually will start from redox, because redox is something that is related to the current topic that we are studying, rate of reaction. So just quickly, all students please give a thumbs up or thumbs down. Chemical equilibrium is part of reversible reaction. Yes. It's a part of reversible reaction. Okay, everyone. See you tomorrow. That's all for today. Have a nice day.